Okay, so this will be video 2 in a series on graphing. The first video was on the rectangular coordinate system, so if you haven't watched it, go watch it first. This video is going to cover what is a linear equation in two variables, what do solutions to linear equations in two variables look like, and how does that relate to a graph. Okay, so let's get started. Okay. So first of all, we need to know what a linear equation in two variables is. Hopefully at this point you're very clear that linear means line. So we are going to be talking about what the equations of lines look like. So a linear equation in two variables is any equation of the form ax plus by equals c, where a, b, and c are real numbers such that a and b are not both 0. Okay, so a linear equation in two variables is any equation of the form ax plus by equals c, where a, b, and c are real numbers such that a and b are not both 0. So the two variables here would be x and y. A and b are the coefficients of the variables. They're just going to be real numbers. And then c is going to be some constant, again, a real number. And by real number, we mean those coefficients and constant could be fractions, decimals, integers, whatever. The only condition on a and b is that they're not both 0. In a future video, we'll talk about what happens if one or the other is 0, but in this case, just know that a and b can't both be 0. If a is 0, that means the x term disappears because 0 times x is 0. If b is 0, then b times y would be 0 times y, or 0, and you'd end up just getting 0 plus 0 equals c, and that's rarely going to be the case. Okay, so again, a could be 0, that's fine. B could be 0, that's fine. We'll talk about what that means later, but just know that a and b cannot both be zeros. Now, you're dealing with two variables. If you go back to just solving linear equations in one variable, we know the solution to a linear equation in one variable is just one value. So for example, if you have an equation where the variable is x, you might get that x is -2 or x is 10, whatever. In this case, though, we have two variables, so we need to understand and know what those solutions would look like. So solutions to these equations are the set of ordered pairs that satisfy the equation. Whoops. Now, here's the deal. Back in just when you're dealing with solving equations in one variable, you would get a single value solution. Okay, so there was one number for x that satisfied that equation, and satisfies the equation just means makes the equation true. Okay, so in this case, solutions to these equations are the set of ordered pairs, all of the ordered pairs that satisfy the equation. I want to go ahead and put here, there are infinitely many ordered pair solutions for any line. So let's think about that. Let's say we have this situation here. So we have a miniature Cartesian plane. I'm showing that the x-axis goes from -4 to +4, and the y-axis goes from -4 to +4. But these arrows right here indicate that this really goes on forever. We're just getting like a little snapshot of the Cartesian plane. Okay. So let's say I have a line and it's going to go through these points right here. So I can see the line goes through the origin. I can also see that the line goes through the point 1, 2. Well, that would be 2 solutions to the equation. So this all means that the solutions are the points that make up the graph of the equation. All right. So these 2 points, if we look at this little graph right here, these 2 points, 0, 0, and 1, 2, these would be solutions to some equation, but they're only 2 of infinitely many solutions. You have a solution here, 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 in between all of these. You have some down here, down here, down here. This line goes forever. So technically, these ordered pair solutions go on forever. When we graph a linear equation, we're just looking at a snapshot of the solution to the equation. So in short, the solution is the graph of the equation. And just keep in mind, we're getting a little snapshot of that solution because we can't possibly graph the entire line. That line goes on in both directions forever. So we're just looking at a little tiny snapshot of the solution to the equation. The solution is all of the points that make up the graph. So that just means it's all of the ordered pairs that satisfy the equation. Okay, that's a lot to take in. So really read through that and kind of make sure you understand that concept. But for now, let's look at very specific solutions and examples, okay? So first of all, let's determine if the following ordered pairs are solutions to, let's say we have y equals 2x minus 5. All right, so we want to know if the following ordered pairs are solutions to the equation y equals 2x minus 5. So this looks a little different than the generic equation I gave you over here. It looks a little different than ax plus by equals c, but this is still a linear equation in 2 variables. You've got 2 variables, x and y. You've got real numbers, 2 and negative 5. And we know something is linear. This is really important. We know something is linear when the exponent on the 2 variables, x and y, is 1. So what makes this linear is the fact that you have y to the first power and x to the first power. But anyway, moving on, I'm going to give you examples of ordered pairs. We want to know if they're solutions to this particular equation. So let's start with -2, 11. Now, if we go back, we know that the solutions to these equations, these linear equations in 2 variables, are the set of ordered pairs that satisfy the equation. What we mean by satisfy the equation is if we plug those values into the equation, we get a true statement, okay? So let's say we have y, which is really 11, x, which is really -2. So I get 11 equals 2 times -2 minus 5, all right? So 11 equals, well, 2 times -2 is -4. -4 minus 5 is -9. Does 11 equal -9? No. So this is not a solution. All right. Let's look at another example. Let's look at 0, -4. Is that what I want to do? I don't think that's what I want to do. Let me double check and get a good one here. 2x minus 5. Let's look at 0, -5. Okay. So in this particular case, x is 0 and y is -5. So I'm going to plug those into the original equation. So 0 is going to be x, -5 is going to be my y. Now 2 times 0 is 0. So I get 0 equals 0 minus 5, or -5 equals -5. That's true. That's a true statement. So we would put yes right here. All right. So for the first example, when we plug in 2 and 11, we got a false statement. We got 11 equals -9, which is not true. That means that ordered pair does not satisfy the equation. All right, but then we tried the ordered pair 0, -5. When we plugged in 0 for x and -5 for y, we did get a true statement. That tells me that that does satisfy the equation. Therefore, 0, -5 is a solution. Let's do one more. Let's try the ordered pair 4, 3. So y is 3, x is 4. So I get 3 equals 8 minus 5. 2 times 4 is 8. And then we subtract the 5. So 8 minus 5 is 3. Whoops, I'm out of room there. So let's see, we get 3 equals 3, which is true. So we would say, yes, this is another solution to the equation y equals 2x minus 5. Now, this is just 3 examples. Remember, there are infinitely many solutions to any linear equation, because remember, the solutions are the points that make up the line of the graph. And lines go on forever. That means there are going to be points forever and ever and ever that satisfy that equation. We just have a couple of examples here. All right, let's look at some more examples of how this could work with solutions. So what we want to do for this example, I want to find the ordered pair solution for, let's try 3x plus y is 9. And we want to find the solution when x is -1. So basically what we're looking for is we're looking for an ordered pair where x is -1. We just don't know what y is yet. So we want to figure that out. Well, what could we do? We have the equation, we have an x coordinate. What we need to know is the y coordinate. So what I'll do is I'll take this equation, 3x plus y is 9. I'll replace the variable with whichever coordinate I'm given, and then I will solve to figure out the other leftover coordinate. So we know what y is, so I'm going to, or we know what x is in this case. So I'm going to take 3 times x, where x is really -1. And then I get plus y is 9. I'm going to go ahead and solve the equation. So first I need to multiply 3 and -1. So I get -3 plus y is 9. My goal is to get y alone. And the issue with y is I've got this this -3 being added in. So I want to move the -3. The way we undo that -3 is with +3. So the 3's cancel and I get y is equal to 12. That means the ordered pair solution for 3x plus y equals -9, when x is specifically -1, would be the ordered pair -1, 12. And that's it. All right. Let's try another one similar to that. So we're going to find the ordered pair solution for, let's see, we have -6x plus y is -1. All right, so we want to find the ordered pair solution for -6x plus y equals -1 when y is -7. So this is just like the previous example, except instead of being given the x coordinate, I've been given the y coordinate. So what we're looking for is an ordered pair where y is -7. We need to figure out what that x coordinate is going to be. So I want to take the equation and I want to replace the y with the y coordinate that's given, and then we'll solve for x, and that'll tell us the x coordinate. So I get -6x plus -7 is -1. So plus -7 is really just the same as -7. So this is really -6x minus 7 equals -1. I want to isolate the x term. So the first thing I have to do is deal with that -7. So I'm going to add 7 to both sides. That leaves me with -6 equals 6. On the left, the 7's canceled. On the right, it simplifies to 6. I divide by -6. And I get that x has to equal -1, and that's it. So now if you were to plug in -1 and -7 into that original equation, you would get an ordered pair that satisfied the equation. You'd get a true statement. So find the ordered pair solution for -6 plus y equals -1 when y is -7. I get the ordered pair -1, -7. Let's do one more like this. So let's say we want to find the ordered pair solution for -3x plus 2y is 14 when x is -1. I've got a lot of -1s here for x. That was not planned. All right. So just like the previous examples, we're going to take the equation that's given to us, and we're going to take the variable that we have a coordinate for. We're going to plug that numerical value in, and then we're going to solve for the remaining variable, and that gives us the other coordinate. So in this case, we have the x coordinate. We're going to plug the x coordinate in for x in the equation that was given. We're going to solve for the other variable y. That solution will give us the y coordinate that completes this ordered pair. So I get -3 times x, which is really just -1, plus 2y is 14. All right. -3 times -1 is 3, plus 2y is 14. Now I want to isolate the 2y, so I'm going to subtract the 3. That gives me 2y equals 11. And then to finish solving, we need to undo the multiplication of 2 and y. I divide by 2. The 2's cancel, and I get y equals 11 halves, or 5.5. So I'm looking for the ordered pair that satisfies this equation, -3x plus 2y equals 14. We knew that x had to be -1, and now we know that y is 5.5, or you could do 11 halves. And there you have it. So basically, if you need to find an ordered pair solution, as long as you have one coordinate, you can plug that coordinate in, solve, and you'll get the remaining coordinate that gives you that ordered pair that satisfies the equation. All right. Sorry, I had to get a sip of water. Now, another thing that you're going to have to know how to do is deal with a table of values. So table of values. So this is a table with columns that represent x and y coordinates for ordered pair solutions to linear equations. Now, you can use these table of values for equations that are not linear, but in this case, again, at this moment in your math career, we're just looking at linear stuff. So let's say that we have y equals x plus 1. Well, let's say that we have a table of values. So right here, I just drew a table of values. You have a column for x coordinates. You have a column for y coordinates. Sometimes you'll see a third column where they go ahead and put the ordered pairs together. It just kind of depends on the book, the website, the person. All right. So for this example, let's say that x was -3. Well, what we do is we take x, we add 1, and that gives us y. Well, if x is -3, I would take -3 plus 1. That would give me -2. So an ordered pair solution for this equation is the point -3, -2. That is a point on the graph of y equals x plus 1. You could pick any x value. Let's say we choose x is 0. Well, if I plug in x, I would have to plug in x is 0, add 1 to that. 0 plus 1 is 1. That gives me a second ordered pair solution to this equation. That's another point on the graph. Let's say we pick another one. Let's say we choose x is 5. Well, I plug in x, so x is 5. So 5 plus 1 is 6. And there I have another ordered pair solution to this equation. That right there gives me 3 solutions, or 3 points on the graph of the equation x plus 1 or y equals x plus 1. So this right here, it gives you points on the graph of the equation. So that's basically what a table of values is. It helps you just organize ordered pair solutions to equations. So let's look at another example. So let's say I asked you to fill in the table of values for y equals 2x minus 7, okay? Now, in some cases, you'll have a table of values that's partially given to you. Other times, you'll have a table of values where you just have to start it from scratch. But in this case, we have a table of values that is partially filled in. So I have -2 for x. I have an ordered pair where y is -7. And then I have another ordered pair where x is 4. So what we're going to do is we're going to take these coordinates one at a time. We're going to plug them into the given equation. We're going to solve. That's going to tell us the other coordinate. Okay. So first up, we have x is -2. So I take y equals 2 times -2 minus 7. Well, 2 times -2 is -4. And then I'm going to take -4 minus 7, and I get -11. So that tells me the pair, the y coordinate pair for the x coordinate of -2 has to be -11. Those two values are tied together forever. For this particular equation, if x is -2, y has to be -11. So we have the ordered pair -2, -11. And then you just kind of lather, rinse, repeat. This is not necessarily the most fun you're ever going to have. It can be a little tedious, but the cool thing is it's tedious, but it's not really hard. And it gives you a really good idea of what the equation of your line is going to look like. So next up, we have that y is 7. We don't know the x coordinate, but we can easily find that. We're going to plug in -7 for y. And that equals 2x minus 7. Well, I want to get the term that contains the x alone, and the issue is this -7. So I'm going to add 7 to each side. So that gives me 0 equals 2x. I need to undo the multiplication of 2 and x, so I divide each side by 2. 2's cancel. I get x equals 0. So now for this particular equation, y equals 2x minus 7, if y is -7, x has to be 0. These two coordinates are tied together forever for this equation. All right, one more. In this case, we have the x is equal to 4. So I get y equals 2 times x, which is 4, minus 7. Well, 2 times 4 is 8. So I get 8 minus 7, or y is equal to 1. So for this particular equation, y equals 2x minus 7. If x is 4, y has to be 1. So that gives me another ordered pair solution to this equation. This right here represents 3 points that we know are on the graph of y equals 2x minus 7. If we were to take a Cartesian plane and plot those 3 points, we would have a really nice sketch of the graph y equals 2x minus 7. Let's do one more table of values. So we're going to complete the table of values. Let me go back to black ink. We're going to complete or fill in the table of values. For, let's do 8x minus 2y equals 10. And this is another table of values where it's partially filled in for you. So we have -3 for x. We have an ordered pair where y is -1. And then we have another ordered pair where x is 4. So again, just like in the previous example, we're going to take these coordinates one at a time, plug them into the equation, find the remaining coordinate, and that's going to give us ordered pair solutions to this equation. So let's start with x is -3. I take the equation, 8x minus 2y is 10. I replace x with -3. So I get 8 times -3 minus 2y is 10. Well, 8 times -3 is -24. So now I have negative 24 minus 2y is 10. I want to isolate the 2y, and the issue with the 2y is the fact that there's this minus 24. I need to undo the minus 24, so I'm going to add 24 to both sides. All right, so the 24s on the left cancel. I'm left with negative 2y equals, well, let's see, 10 plus 24 is 34. So now I have negative 2y equals 34. The last step here to get the y coordinate is I need to undo the multiplication of 2 and y, or negative 2 and y. So I'm going to divide both sides by negative 2. On the left, the negative 2's cancel, leaving me with just one y. And then 37 divided by negative 2 is negative 17. So for this particular equation, if x is negative 3, y has to be negative 17. And that gives us the ordered pair negative 3, negative 17. Okay. And like I said in the previous example, this is not the most exciting stuff you're ever going to do. It is a little bit tedious, but it's not particularly difficult. And really understand what you're doing now, because there are going to be different ways to graph linear equations. But in future sections or in future math classes, you might need to graph something that's not linear. And a lot of times going back to this point plotting method is really the easiest way to approach graphing. So make sure you kind of learn and understand this. Okay. Now we want to find the ordered pair that satisfies the equation 8x minus 2y equals 10 when y is equal to negative 1. So I'm going to take the equation. I'm going to replace y with negative 1. That gives me 8x minus 2 times negative 1 equals 10. Negative 2 times negative 1 is really just plus 2. So I get 8x plus 2 is 10. I need to isolate the x term. The issue is this plus 2, so I'm going to subtract it from both sides. On the left, the 2's cancel. 2 minus 2 is just 0. So I'm left with 8x equals 8. And now I want to undo the multiplication of 8 and x, so I divide each side by 8. And that leaves me with x equals 1. So for this particular equation, in the event that y is negative 1, x has to be positive 1. That gives us another ordered pair solution, 1, negative 1. That is another point on the graph of the line 8x minus 2y is 10. Let's do this one more time. All right. So in this last example, 8 has to be 4. So let's figure out what y has to be if 8 is 4. So I get 8 times 4. I'm going to replace the x with 4. Minus 2y is 10. Well, 8 times 4 is 32, so I get 32 minus 2y equals 10. I need to get the 2y alone, and the issue here is this 32. So since 32 is being added on the left, I want to subtract it, and I'm going to subtract it from both sides. The 32's on the left cancel. 32 minus 32 is 0. That leaves me with negative 2y equals negative 22. Now I need to undo the multiplication of negative 2 and y, so I divide. Negative 2 divided by itself is 1. 1 times y is y. And then negative 22 divided by 2 is 11. So in the event that x equals 4, y has to equal 11 to satisfy the equation 8x minus 2y is 10. Now we have 3 points on the line. So these are 3 points on the graph of the line. Eight x minus 2y is 10. Okay, so make sure as you work through this graphing that you understand what a linear equation in two variables happens to be and what the solutions to those equations are. Let's look at 2 more examples. One will be a word problem, and the second one will just be something a little outside the box, okay? So I have never taken a taxi in my adult life. These numbers are completely made up. It might not be realistic, but anyway, the cost to take a taxi is $3.50 plus $2.25 per mile. The equation C equals 225 M plus 350 represents the cost C of taking a taxi M miles. Okay, so this is a linear equation in two variables. The variables are C and M. We're told that C represents the total cost, M represents the number of miles. Okay, so let's answer some questions about this. How much would it cost to take a taxi 7 miles? Well, you have to make sure you understand cost versus miles. So in the equation, C represents the total cost, M represents the number of miles. And so right here, we have a value for M, okay? So what we want to do is we want to take the equation C equals 2.25 M, but in place of M, we're going to plug a 7, and we want to add 350 to that. So let's see what we get. 2.25 times 7 is 1575. So the cost so far is 1575 plus the flat fee of 350. So basically you have to pay 350 to take this taxi 1 mile or 200 miles. And then you pay additional cost for each mile driven. So if we take the cost for the mileage, the 1575, and we add the flat fee, the total cost for taking this taxi is $9.27 for a 7-mile ride. Okay. Now, what if we switched it up a little bit and I said, okay, you pay $26 for a taxi ride. How many miles did the taxi travel? So this example is a little bit different than the previous example. In the previous example, we were given a number of miles. In this example, we're given the total cost. So 26 right here represents C, okay? So I would get 26 equals 2.25 M plus 350. I want to solve and figure out what M is. So what I need to do is isolate the term in this equation that contains the M. The issue is 2.25 M has a 350 added to it. So let's subtract 350. All right. So that's going to be 2250 equals 2.25 M. 350 is on the right side of the equation canceled. Now I've got my M term alone, but I need to isolate it. The way I isolate the M is I undo the multiplication of 2.25 and M. So I'm going to divide on both sides, 2.25. The 2.25s on the right cancel. 2.25 divided by 2.25 is just 1 M. And then 2250 divided by 2.25 is 10. So 10 miles will cost $26. Don't forget to label your final answers, okay? Naked numbers don't mean anything. If you just did C equals 19.25, my question to you would be 19.25 what? 19.25 inches? 19.25 donkeys? No, $19.25 to ride 7 miles in the taxi, okay? Last up would be, let's see, interpret the ordered pair 22, 53 if ordered pairs of the form M, C satisfy C equals 2.25 M plus 350. So basically we're told that ordered pairs of the form M, C, so the first number is M, which means miles. The second value C is the total cost, or kind of like our Y's. So again, M equals miles, C equals cost. And these ordered pairs satisfy the equation C equals 2.25m plus 3.5. What they want us to do is, hey, we've got this ordered pair 2253. What does that mean? So what we would say is this means a 22-mile, so remember the first number is m is miles. It means a 22-mile taxi ride costs $53. Remember the second value is C, or total cost. And there you have it. All right. So this is just like the previous examples where we were plugging stuff into equations where we had X and Y, but now you have a real world scenario kind of behind the scenes giving us the equation, and now you know how to interpret that. Okay. Last example says find the value for K for which -2, 17 satisfies y equals -4k plus, whoops, I wrote that wrong. Y equals -4x plus k. So you have to figure out what this value k is, okay? We know that x is -2. We know that y is 17. So what we need to do is plug those two coordinates in that ordered pair solution into this equation and solve for k. So y is 17, and that equals -4 times x, which is -2. We've got this plus k that we're trying to figure out. So I want to simplify. So I get 17 equals, well, -4 times -2 is 8. So now I've got 17 equals 8 plus k. I want to isolate the 8. No, I want to isolate the k. So I'm going to subtract the 8. Well, 17 minus 8 is 9. On the right, the 8's cancel, leaving just a k. So we could say k equals 9. Okay, so that's just a weird little example. It's basically exactly like what we did here when we had find the ordered pair solution for 3x plus y equals 9 when x equals -1, except in this case, we didn't have that constant 9. We had values for x and y. So it's the same deal. You're just plugging in what you know and looking for what you don't know. All right, let's do a quick recap. So linear equations in two variables are any equation of the form ax plus by is c, where a, b, and c are real numbers, such that a and b are not both 0. So a could be 0, that's fine. B could be 0, that's fine. But they can't be 0 at the same time. In the next video, we'll talk about what it means when a or b is 0. But for now, just know that a and b cannot both be 0. Solutions to these equations are the set of ordered pairs that satisfy the equation. Okay, there are infinitely many of these ordered pair solutions for any line because lines go forever. And what we can see is that these ordered pairs that satisfy the equation are actually points on the graph of the line, and lines go forever. Therefore, you have infinitely many solutions. So in short, the solution is the graph of the equation. So like when we're looking at the graph of the equation, that represents that set of ordered pairs that satisfies the equation. We did an example where we were given an equation and we looked at a series of ordered pairs to determine if they were or were not solutions. We then did examples where we had to complete an ordered pair. We were given half of an ordered pair to an equation. We had to find the corresponding point or the corresponding coordinate so that that ordered pair satisfied the equation. We then looked at tables of values. So tables of values are kind of like what we did here, where we completed the ordered pair. You're just doing several ordered pairs for a single equation, and you're just putting it in table form. So we looked at tables of values. We did that here again. And then we looked at the word problem about the taxis. So this is still right here. Let me outline it in blue. This right here is still a linear equation in two variables. You've got two variables, c and m, both are to the first power. That makes it linear. It's just now we have c representing cost, m representing miles. We did some examples there. And then finally, we did a little bit of an abstract value. What I'm wanting to relay to you here with this example is that it doesn't matter what piece of information you need to find. Plug in the information that you have and solve for what you don't have. Okay, so that is of a broad overview of what a linear equation in two variables is. In the next video, let's see what the next video is going to be. In the next video, we'll talk very specifically about horizontal and vertical lines, and then we'll go much deeper into the point plotting method for graphing. And then from there, we'll talk about intercepts, we'll talk about slopes, we'll talk about slope-intercept form of a line, we'll talk about finding equations. You've got a lot coming, but for now, this video just kind of explains what a linear equation in two variables is. All right, best of luck.